Okay, let's jump in. We'll be on page 3. All right, over here, there's a few more for you to practice using your calculator, which we're already doing. So just take note that we have one process when we're solving for a missing side, like these two. And then we have another process, which is the easier process when you're solving for the missing angle, whether it's x or theta or whatever. You're going to use the inverse function on your calculator. Okay, let's continue to talk here and think about, all right, let's say we have this angle theta, and this is 3, and this is 4. So what we can do is we can figure out that angle right there for a 3, 4 triangle, and I would do the inverse tangent of 4 over 3, and I would figure out that there is only one angle that can fit when we build that triangle. It's 53.1 degrees. All right, so if that's 53.1, we could also argue and start looking at this. Well, we know 2 of the sides already. What about the hypotenuse? We've been ignoring the hypotenuse for a while. We should be able to figure out the hypotenuse by doing Pythagorean theorem. All right, and on this one, you get exactly 5. So I could argue right here, I could say, well, for a 53.1 degrees, if I wanted to set a ratio of the opposite compared to the hypotenuse, because we've always been doing the opposite to the adjacent, but I also could say with certainty the opposite compared to the hypotenuse would be 4 over 5. And I could say the adjacent compared to the hypotenuse would be 3 over 5. These are legitimate arguments right here. There's no going against it, because if that's 3 and 4 was beginning there and it's 53 degrees, and I know that's 5, and that's still going to be a 53 degrees. There's no change in any of this. Just because that's 5, that did not change. Or just because that's 53.1, that's got to be 5. Like there's no getting away from it because of Pythagorean theorem. So what this allows us to do is start branching into some other comparisons. These are the 2 comparisons. And this ratio right here has a name. It's called the sine ratio. And this one has a name. It's called the cosine ratio. All right. These are your 2 new ratios. Here's another example of this over here. It continues to show you, I'm on the bottom of page 3, that this small triangle right here, if I'd compared, they switched the 3 and the 4, which is fine. That's the opposite in the hypotenuse. So the opposite of the hypotenuse is 3 over 5. But if I continue to draw this line out even further, and I extend this line until they meet at a 90-degree angle, and I compare the opposite to the hypotenuse, well, that would be 6 compared to 10, which reduces to 3 over 5. And I could continue this idea and continue to extend this way and this way and make bigger triangles. And when I do compare the opposite compared to the hypotenuse, it's still going to be in a 3 to 5 ratio. And that angle down there is not going to change. It's not going to. All right. And so this is the one that we call sine, right? Opposite over hypotenuse. And this one over here is the one we call cosine. And again, this could be argued for the same thing, just as long as I compare 15 to 17, which is the adjacent and hypotenuse. I could compare the 45. What's 17 plus 34? That would be 51, right? So 45 compared to 51 would be the same comparison as 15 to 17, and it does reduce to 15 to 17 because 3 goes into both of those. All right? And that same argument could be made. It doesn't change this angle. It just continues on this path, and all of these ratios are the same. Okay? So we would say once this ratio is set, the opposite to the adjacent or opposite hypotenuse, whatever, there is only one angle. There's only one angle right here that fits with those. There's only one angle that could have fit. And again, we can figure this out by doing the inverse tangent, or like I'm going to show you, we can do the inverse sine or the inverse cosine. All right. So these are the two new ones. Okay. And now that we have those, we are going to use those to solve some problems over here. All right. And again, just to summarize, in any right triangle, if the ratio of two sides is set, then there is only one angle that will fit in there. All right. Whatever ratio of any two sides. Now, I should say this is a right triangle because remember, if I know two of the sides, say this one and this one, 5 and 11, I'm automatically going to go know this one according to Pythagorean theorem. So just as long as you know two in a right triangle, I can figure out the third and I can figure out both angles. That's the bottom line. There's only one angle that'll fit. And once you figure out that one angle, I can figure out the other angle by triangle sum. Okay? So to say this backwards, we would say if you're given an angle and a side in a right triangle, then the other two sides are set. Right? As a matter of fact, if you go back and think about it, at the very beginning, when we were doing these at the very beginning and you were using tangent, once we found x as being 3.4, we could have done Pythagorean theorem to find the hypotenuse on every one of these problems. So like we said, if you know an angle and you know a side in a right triangle, you automatically can find both other sides and the other angle. All right. We probably could start making some more charts right here. And I would do my experiment again, like we talked about, where we set a set measurement down here. Like if we set the 52 degrees again, like we did, and we drew that in, and we started doing some figuring. Now, when we first did this experiment, remember, we were only comparing the opposite compared to the adjacent. But we could measure the opposite and compare it to the hypotenuse. Actually, I need to do opposite. I just said opposite. That would be 9.5 and compare it to the hypotenuse. Now we know the hypotenuse should be bigger. Okay, it looks like it's right at 12. So if I set that at 52 degrees and I'm saying the opposite compared to hypotenuse is 9.5 over 12. 9.5 over 12 does have a decimal to it. Okay, 0.7916. We also said, do you recall what we said the name of this was? It's called the sine ratio. We simplify it, S-I-N. All right, and if you're thinking about it, yes, that is in our calculator. Okay, I could just type in the sine of 52 and look that ratio up. See, I was pretty close with my just really quick measurements right there. All right. So again, what that allows us to do, and I might show you some other trig tables just to show you the way I used to do it before everybody had a calculator in their hand. I'm dating myself here. Okay, we had to flip to the back of the book every problem when we had to look these up. All right, depending on, you had to look up your angle and you would know the ratio this is the ratio for opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. So the one we looked up, I only showed you the tangent ratios, okay, which is this column right here for every one. But now we do have some that are for sine and cosine. And again, It is a lot easier just to type this in the calculator. The sine of 52, like we said a while ago, was this. That's what we found out in our calculator. Now, what does that allow me to do? That allows me to do these problems down here, which are your prototypical trig style questions. So what you're going to have to do now is you're going to have to think before you jump into this process. Now, here's the good news. You already know the process, but you're going to have to think, is this situation, is it sine, cosine, or tangent? You're going to have to decide. And so if I look at this angle's point of view, I know that this over here is the opposite, and this right here is the hypotenuse. So I know that it's sine. A little pneumatic that we use to help us remember this is this right here, SOHCAHTOA. Sounds weird to say, but what it's telling you is the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, the tangent is opposite over adjacent. As a matter of fact, everybody in the United States, every textbook uses this. And a lot of students will probably say, "What are y'all doing in math?" They'll say, "Well, we're doing SOHCAHTOA," and that's just what they call it. They don't even call it trig because they keep using this on every problem. Okay, it's these three ratios that we do. So if I see I'm using the opposite in hypotenuse right now, I know that I should be using the sine ratio. So I start my formula out like this: the sine of 54 equals 9 over x. The process is the same. So I'm going to go type in sine 54. Actually, I'm not even going to do that. I don't want to know that decimal. Same thing that happened last time. If you think about what's going to happen right here, when I cross multiply this, the 9's on the top, it's really going to be 9 divided by whatever that is. So let's not even write it down. Let's just cut out the middle step right here and say that's 9 divided by sine of 54. That would be the fastest way to do it. And there's my answer, 11.1. Okay. Number 2, this angle point of view. To me, I always orient myself from that angle's point of view. I know this side over here is the opposite, but hey, look, we're not going to use the opposite on this one. So what's the left? There's only 2 left. This is the adjacent, and this is the hypotenuse. So I'm going to set my problem up. Cosine of 56 equals x over 14. All right. Think about the algebra right here. It's going to be 14 times whatever the cosine of 56 is. Done. 7.8. Okay. You continue to do these the same way. You just have to decide. And what you should be able to do now is you should be able to practice this on page 4, page 5, and down through page 6. All lots of practice for you deciding what's going on. And something, if you'll notice, once you get going over here, you start to figure out that, oh, now I'm solving for the angle. Well, remember how we did this. When you're solving for the angle, remember, these are the easier ones. I have to decide, though, this is the opposite. This is the hypotenuse. So I can tell by SOHCAHTOA that would be the sine. So I would say that it's going to be the inverse sine, to go look this up backwards, of 5 over 13. Okay, so I would go and type that in. Second sine, 5 divided by 13, 22.6 degrees. All right, finish through page 6. All of that practice, you need to do every one of those for yourself. You have to go through that process of you deciding which one that is, because I can look at this right now and tell me that's cosine, but I don't know if you can do it that fast, but eventually you will if you practice.